All right, so as we've been talking about with substitution, sometimes our integration using substitution requires a little bit more manipulation than what we've seen. So we're going to check out an example of that. So in this problem, you can see that this 2x minus 1, that's kind of our function within a function. I'm going to use a highlighter for that. So that's what we're going to set as our u, okay, just like we were doing before. So u is going to be 2x minus 1, which makes du 2dx. Now we don't have a 2dx in the problem, we just have a dx, so we're going to divide both sides by 2. So we get dx equals du over 2. So that's going to take care of this piece and this piece. So we can plug in our u and we can plug in our du over 2. But notice we still have an x in the problem over here. So what we're going to do to deal with that x, to deal with this problem, is we're going to come back to our original u. And we're going to solve this for x. So this becomes u minus 1 equals 2x. And we're going to divide both sides by 2. So x is u minus 1 over 2. And that's what we're going to sub in. So when you sub all of those pieces in, that x equals u minus 1 over 2. Underneath the square root is just the u, and over here our dx is du over 2. So now we've done substitution and everything's in terms of u. So now we just need to clean this up. The first thing I'm going to do is factor out both of the 1/2s. So I'm going to pull that out as 1/4, which gives me u minus 1, and then this is u to the 1/2 du. And then we'll distribute that. So we get 1/4 u to the 3/2 minus u to the 1/2 du. And this is something that we can take the antiderivative of very easily. We're running out of space. Let's put that over here. So it's going to be 1/4. Antiderivative of u to the 3/2 is going to be u to the 5/2, and we'll need a 2/5, minus u to the 3/2. We'll need a 2/3 to balance that. Of course, we'll need the plus c. And then I'm going to distribute my 1/4. So that's going to give me, when I reduce, 1/10 u to the 5/2 minus 1/6 u to the 3/2 plus c. And then the last step, we'll substitute back in for our u. So 1/10 2x minus 1 to the 5/2 minus 1/6 2x minus 1 to the 3/2 plus c. Okay, so it's still the same process, it's just a little bit more manipulation to take care of this little extra x that we had in the problem. So let's try another one like that. So for this problem, we probably want our u to be, I'm going to guess down here. Let's set that as our u. So 3x squared plus 5, which makes our du 6x dx. Now, we can do this a couple different ways, but when I look at this and see it, I notice I don't have a 6x dx in the problem, I have a 2x dx. So what we could do is we could turn this into a 2x dx, like if I divide both of these by 3, that's going to give me du over 3 equals 2x dx, and that's exactly what I have here. Now, that's not the only way you could do it. You could factor out the 2 and then just divide both sides by 6 like we've normally been doing. But however you approach that, we somehow need to deal with that too. So what I see here is, remember this was my u, so I'm going to replace that with u. And then this whole thing, this 2x dx here, that's going to get replaced with du over 3. Okay, and now I'll factor out that 1/3. So we have 1 over u du. Antiderivative of 1 over u is natural log, so 1/3 natural log of u, absolute value of u, plus c. And then to finish out the problem, we need to substitute back in. 1/3 natural log of 3x squared plus 5. I actually don't need the absolute value now looking at this because 3x squared plus 5 is always going to be positive. So there's no need for absolute value signs on that one.